what we're doing today. Okay? Today, last class we learned transformations. I want to kind of review with you. We were on a time crunch big time, but there were 3 parent functions that we learned how to transform. What were those 3 parent functions? Square root. Okay, so this is linked on Canvas. We had the square root graph. We are going to come back to square root graphs next class because we're going to talk about inverses with those, but not till next class. You do have to transform a square root on your homework. Then we talked about cubics and cube roots, which I kind of was saying these guys are inverses, and we're going to talk about that today. Remember, those critical points of a cubic and a cube root are flip-flops of each other, and we're going to talk about that when we review inverse properties. But we transformed those. We need to know all these transformation rules, especially if you're retesting, you too. Especially if you're retesting Unit 4, Topic 1, you're going to have transformations on there, taking out the B. I only did one of each with you, but I have everything in Canvas. I chose to do what I thought was the harder one. You had to factor out B values and stuff on every one that I did, but I worked out those. So if you are stuck on your homework, make sure that you know where this is. I'm on the notes key right here for 7.3. So we did square root graphs, and we did some cubic graphs, and then we did cube root graphs, and they kind of look like that. So I will be talking about the shapes of those graphs and their attributes and stuff over the next 2 days when we talk about inverses. Just a reminder, next class is another day on inverses. I'm hoping to carve out some time to talk about course selections with you. And if you are a person who is not going to be here Wednesday or is taking 4 retests, we can probably get 1 retest done in class Monday. Fingers crossed, that's the plan. Otherwise, the rest of them will be done on Wednesday or Power Lunch Tuesday if you've communicated that with me. But that will be the plan for that, but we do need to knock all that out next week. And then retest people. Remember, I put all these up here, blank test reviews and answer key reviews. We've done warm-ups over Unit 4 and 5. I'll make up something for Unit 6 on Monday that we can review then. And then I'm going to email out that video for AP Pre-Cal for you to watch and get an idea. Have an idea of what you think you want to sign up for on Monday. Okay, so we can have discussions. I think that's everything I was going to talk about for... I'm going to do a homework check on Monday, which means what homework needs to be done? 7.1, 3 questions. You have space to do all those 3 questions on your paper. I have it up here, so you can do all the work there. 7.2 is on the back. You do not have space. It is 6 questions. I have it all worked out here, so you can come check for that. So I will be checking at the beginning of class on Monday. You have to have it with you. You have to have it done at the beginning, not 20 minutes later, not 2 days later, not any excuse you're going to give me or what happens.
Academic glitch.
Make sure we're all clear on that.
On the last week of school.
On the last week of school. And if you don't go, then it will carry over to the first week. And that's not how you want to start your year.
And if you don't do it, do you not...
Well, here's the deal with this. There is Unit 7, Radicals. We did not have time to have a test this quarter. We also are changing or splitting. This used to be 1 unit where we would do these couple lessons plus what we're going to do in January. And then we do a big test in the spring. Well, not that big of a test, but we do a 2-part test in the spring. Our plan right now is just to teach this and practice this stuff, and we were not going to assess you on it. However, this has happened last class, and you already know I was complaining about it. Just because we're not going to do a test on these topics per se doesn't mean it's not important. The skills that we're going to talk about today, especially with the solving, are going to carry over in January when we solve these types of equations. But I am reserving the right to go to the other Algebra 2 teachers and say, you know what? my students just totally blew off Unit 7. So I think we should include that on our next test. We can do that. And I don't want to do that because that's kind of mean to make a 2-week break. But technically, we still could continue and test you over this material if we can't handle learning when there's no test with it. Do you understand what I'm saying? You understand that I'm kind of irritated by people just not thinking this is important? It is important. And I promise, if you get what we're doing right now in January, that solving is not going to be too terrible. So yes, you need to have the homeworks done, because if I do lump this on your next test, it will be a part of the requirement to answer your question. Yes. Once upon a time, back in, I don't even know, September maybe, we did a lesson about inverses with linear functions, and I said, hey, you're going to see this stuff again one day. It's one day, okay? So here it is. Chromebooks, close, all of you, with them out. No. We're on 7.2 right now. So we are talking today, we're just going to focus on cubic and cube root functions. Finding their inverses. And then our next lesson is going to be dealing with square roots and quadratics. I don't know about you guys, but if you had to choose like even number or odd number, what are you more likely to choose?
Even.
Okay, I feel like this is like the most popular opinion ever. No. Okay, so like I was saying, one day you were going to come back to the inverse stuff. That day is today. Here we are. Okay? Just a review, when we graph an inverse function, which we're really not going to do a whole lot of graphing in here, but it applies to when you do it algebraically as well, you switch your inputs and outputs. So remember, I told you parent functions, cubic and cube roots, those are inverses. That's why their critical points that we graph with are just reverse of each other. And we'll look at that also. Graphically, if you were to graph these, the inverse graph will be a reflection over the line y equals x. So they just are flip-flopped over the linear parent function. And then sometimes the inverse function will be a function, sometimes it will not. That's why we're splitting this into 2 separate days. Today we're going to live in inverse is always a function. Next class, it's not. So we're going to have to fix it. Here's a definition you've heard before. If a function is 1-to-1, you remember that? If a function is 1-to-1, then its inverse will be a function. Okay? So we like 1-to-1s. To be a 1-to-1, what does it mean to be a function? What can't repeat just to be a function? Like Algebra 1, what did you look at? The x's. The x's can't repeat. What test did you do to tell if something was a function? Vertical line tests. 1-to-1s are also functions, but they're a subset of there. Each output cannot repeat. All right, hey, Anshul, front table now. Now. Okay, each x won't repeat, y won't repeat. And then that's how you tell if you have a table of points. But then you also can look at a graph and do the horizontal line test. And I know we talked about that before. Okay? So that tells us, Graham, you with us? Yes. That tells us if a function is 1-to-1. And we want to deal with 1-to-1 functions because the inverses will also be functions. We like functions. Okay? Inverse notation, you've seen this before. It's the f inverse x. You can only use that if the inverse is actually a function, which we ensure that they are, so it's okay to use that. You can also use y inverse. I'm not really picky about it. I do always do my answer keys with f inverse x because, again, we're making sure they are 1-to-1. So here's our first parent function we're going to look at is the cubic parent function. We did this last time. We transformed it. We talked about its features. We talked about its critical points. Here's what the graph looks like. All is fun with that. So the first question is the cubic function a 1-to-1? So if I look at this guy, is it a 1-to-1? And I want you to be able to tell me from the table. I want you to be able to tell me from the graph. So yes or no, is it a 1-to-1?
Yes.
Yes, it is a 1-to-1. Okay? How do you tell from the graph? That one's probably more familiar to you.
Horizontal.
It passes the horizontal line test. Passes the HLT. So if you take your graph right here, draw horizontal lines, they're only going to cross one time. Okay? From a table, how you can tell from that, I Kind of talked about that up there. To be a function, x's can't repeat. To be a one-to-one function, what else can't repeat? Y's. So we would say no x's or y's repeat. You can have a function that has repeating y's. A quadratic has repeating y's. But those are not one-to-one. Therefore, preview of what we're doing next time. But so if you look at these here, no x's and no y's. So based on your answer, knowing that the cubic function is one-to-one, is the inverse of the cubic function going to be a function?
Yes.
Yes. Why? Because f of x is one-to-one. And then to find the equation, so let's say my original equation, I do take away the f of x when I do this algebraically. What is f of x the same thing as? Y. So if this is my original, y equals x to the third, if I solve this algebraically, which is what we're going to do over the next couple pages, I first switch the x and the y, so I would have x equals y to the third power, and then I solve it back for y. So how do I undo something being to the third, raised to the third?
Do it to the other side.
No, can't divide it. Cubed root 3, okay? You take, instead of a square root, you're taking a little cubed root like that, okay? And so that undoes that exponent, and that will leave me with y inverse equals cube root x. And that is the inverse equation, which I'm going to scooch the page back up, and I'm going to go write that right there.
How is that y inverse?
Because when you get the y isolated, because I switched them from the original, that when I get this y by itself, it is the inverse.
Wow.
Cube root x. And then you can also, like I said, with all these points, those are going to be flip-flop, but we already know this because we did this last class. The original points of f of x equals cube root x is, 8, 2. Those are your parent function points. And then your graph looks still kind of a twist through it, but it is more side to side, okay? And those are a reflection over the line y equals x. If you were to draw the linear parent function through there, you'd see each of those points are just flipped over. We're not going to do too much graphing with this. We're going to do it more algebraically. But again, it is important for you to know those. Oh, I was talking about evens and odds. Oh, what's your question, first of all?
Could you go from y equals x cubed to the next one again? I didn't exactly.
Wait, what?
Like, could you go from the first one to the second one? In number
From this one to this one?
no, in number 4, like the first thing to the second.
Oh, I switched x and y.
Oh,
Because that's how you find it inverse. You switch your inputs and outputs, your domain and range, and then you solve it back. I was talking about evens and odds, and then the phone rang, right?
Yes.
Okay, and we all said we would prefer evens, right?
no.
When I was talking about that, yeah. Okay, this is the one unit, though, that actually, odds are easier. Because, and I talked about this last class, you can raise something to a third power or a fifth power or a seventh power and get a negative. You can take a third root or a fifth root or a seventh root of a negative. Odds, they see no wrong. Their domain and range are all real numbers. There's nothing kind of tricky about that. Even functions, square roots, fourth roots, sixth roots, they kind of have some trickiness with them, and it makes them not as great. And this is the only time that evens are not as great as odds is in this unit. So that's why we're doing these odd ones first. Okay, sorry, that just randomly came back in my head that I started mentioning that, and then I got distracted. So here we go, flip over. There's two methods that we use to write the inverse of a linear function. I think for the most part, most people prefer to do it this way. So if y'all are okay, I don't think I'm going to do it that way. Are we okay with that?
Okay.
I'll just show you one way. If you would like to go back to the other one, I'd be happy to work with you on that. It's just not my favorite because these are a lot like more beefed up functions than when we dealt with linear functions. Like there's a lot more places we can have stuff going on with these types of functions. And so to me, this just too tedious. So I'm like, just less is more. But so what we're going to do, we're going to not do that side either. We've got a function right here, and we're going to find the inverse of it algebraically. Go ahead. So the first thing is, instead of writing f of x equals, I'm going to replace f of x with y. This is not really like mind-boggling work here, but I think it's helpful to just replace it. Sometimes I just replace it up here, but I'll write it out for this first one. So the first thing I like to do when I'm finding an inverse is just kind of think about, okay, what parent function am I starting with? What parent function is this? That's not, vertex isn't a parent function. And I've gotten asked that question 3 times now. Okay, that's a form of a quadratic, but you're looking at what is the exponent it's being raised to or the type of root. So since this is an x to the third, this is a cubic function. What do we know the inverse parent function of a cubic is?
The
Cube root. So my answer way down here should end up being a cube root. It seems fairly obvious. However, in the past when we have done tests and quizzes on this, there was always a handful of people that would find an inverse of a cubic and they would say the inverse was just another cubic. And that's all sorts of wrong. Okay, they're always going to be the opposite function at the end. So I kind of like to write that at the beginning just so I have an idea, what am I starting with? What should I end with? Okay, so when we actually find these algebraically, we write it in terms of y. Check. We switch x and y. X equals 1/2 y minus 5 to the third plus 8. This is now, because I did that switch, I'm now going to be able to, when I solve it for y, when I get y by itself, that is going to give me the inverse equation. Cubics are 1-to-1. The way we're going to write them, they're going to be 1-to-1. So my inverse is going to be a function. Life is good. Here's where it's going to get a little bit tricky, and honestly, depending on how this original guy is written and where we've put numbers, that's going to determine how many steps it is to get this by yourself. It's much more advanced than it was with linears. So here's kind of my thought process. And again, this is going to help you when we get to solving these equations next semester. You are getting this variable by itself. The first thing I want to do, though, is get this parent function, the parentheses to the third, all by itself. Okay, I want to isolate the original parent function. Well, what's happening outside of the original parent function right now? I got a 1/2 and I got an 8. I got to move that stuff over and get the parentheses to the third all alone. The order matters. What order do I need to move the 8 and the 1/2 in? 8 has to go first, so I move that by subtracting, and that takes this out. I'm going to move it in one step, and I think y'all should, I don't care if y'all do it in one step as well. So I got rid of that first. It's reverse PEMDAS because we're solving. And then how do I get rid of the 1/2 that's being multiplied? I don't like dividing by 1/2. So what is that the same thing as? But what did I put around the x minus 8 right here? Because both of those things. So I'm okay if y'all do this, add, subtract, over, multiply by the reciprocal. I'd prefer you to do multiply by the reciprocal because that's how I'm going to do it. But you've got to make sure that what x is being added or subtracted to is in parentheses like that. So that takes that away and leaves me with y minus 5 to the third. So that's always the first thing, is move the stuff that's outside. If you think transformations, move the d and the a to the other side. D goes first, a goes next. Okay? Now, I'm not done. How do I undo to the third power? Cube root. And so what I do to one side, I have to do to the... And notice I put that whole 2 times x minus 8 in there. And that's going to unravel my to the third power right here. So I have cube root 2 times x minus 8. You could distribute that too. I don't need you to. And that leaves us with what?
Y minus 5.
Y minus 5. Now at this point, you're going to get that outside exponent or a radical away. And now you're just going to have to peel everything away from the y. In this problem, there's only one thing to move. But there are going to be problems where we have more. Yeah.
Isn't y isn't it like negative?
It will. I don't do the inverse until I get it all the way by itself.
Oh.
Okay? So how do I move away the minus 5 from the y now?
You add 5.
I add 5. So I would have cube root. But when I add it, is it going to go inside that cube root on the other side? No, it's going to go outside. Make sure it's clear to me that that is outside. And now that y is alone, I'd put the inverse. And I'm even going to go take it all the way to putting f inverse x because that's a little bit more formal. And I know that this guy is going to be a function. And so I can write it like this, plus 5. And again, does it check out that I have a cube root inverse equation? Yes. Okay. So we're going to do, there's another problem just like this on the next page I'm going to have y'all do real quick. But before, we also are going to bring back this rule here. And we don't have room to do this one, so it's fine. It's at the end of the notes too. But y'all remember compositions? Yeah. F of g of x, g of f of x. If something is truly an inverse, when you compose them, both of those compositions become x. And that means that they are inverse. So at the end, I'm going to have you guys do some that you kind of have to test it and see. All right, but go ahead, flip over. Here is a second example. Write the inverse function of this. Okay, what is this parent function originally?
Huh?
What is this?
Cubic.
Cubic. Okay, so my inverse is going to be a cube root. I rewrote f of x with y, and then I'm going to switch x and y. I'm doing it in less steps for this problem, but I want you to kind of do this one on your own. I do want to mention something here because last class I got a lot of questions on that. Remember, you've got to get the original parent function by itself. I want to get the parentheses to the third alone. What's in front of that parentheses right now? A negative. So I can't go getting rid of this until I get rid of this. Do y'all know what I'm talking about? So how do I get rid of this negative? Multiply it by -1, or you could think of it as divide by -1 because it's just a -1. But what's going to happen to your x? Very good. My last class was a little confused on that, so very good. Y'all thought that was easy. Now undo the power of 3 and get the y by itself. Okay? It's a couple more steps after you undo the radical, but you got it. Okay, so this one's going to have a little bit more steps after you get rid of the cubed. How do you get rid of the cubed? Cube root. Okay, so this will give me cube root of -x equals 2y minus 5. Got to get y by itself. What has to go first?
-5.
Move it by adding 5. How do I get rid of the 2? You could do all over 2, and it would have to be this whole thing. I don't love that. I like to just keep consistent with multiplying by the reciprocal. What is the reciprocal of 2?
Why is the 1/2?
Why is the what? 1/2. So since there are technically 2 terms here, there's this term and this term, I have to multiply both of these by 1/2, and that will get that by itself. So there's kind of 2 ways that you can write it. I wrote it with the 1/2 and then the cube root of blah, 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 plus 5 in parentheses. I would accept this. That's not how I wrote it on my answer keys, just so you're aware. But the 1/2 does have to be, again, there are 2 terms. There's a term here and a term here. But either way, you end up with the cube root with these. Here's the thing about inverses, and we talked about this last period too, is like a lot of times they look like real ugly. I mean, this looks not pretty to me. But it's more about getting the idea of like moving stuff over in the correct order than it is about cleaning it up and everything. Okay? So let's talk about 3, and then I'm going to have you try number 4 on your own, and then we're going to talk about compositions. Homework time. Yeah.
How come the 2 went inside the square root of 3 last time? They're not this 1/2.
Because the 2 was outside on this one. Your 2 was outside of the parent function. And on this one, the 2 was inside. So that's kind of what we did. A lot of these problems, you'll see some, like, we kind of just change up where we put stuff. So that way you can see the correct order when you move it. Let's look at 3 real quick. First of all, this power of 3 is not supposed to be there. So go ahead and scribble that out. That was typo. Everyone got that? Yes? What is the parent function of example 3 originally? It's a cube root. So what is your inverse going to be?
Cubic.
Cubic. So I would just make a little note. All right, when I get down here, I should get a cubic equation. I do the same thing at the beginning. I switch x and y. None of that is changing. Oops, 3y plus 2 minus 1. Okay, I got to isolate my parent function. I want to isolate that cube root. So what do I have to move this time? I don't have anything to divide, but I do have something to...
Multiply it by the power.
No, what do I do first?
Well,
I have to add the 1.
Oh.
And it's not a multiply. Not a multiply when you get rid of that. It's a raise. Raise to the power of what? 3. Cube both sides. Okay? And what did I put around the x plus 1? Those matter. So I'm going to have x plus 1, the whole thing cubed, will equal negative 3 parentheses y plus 2. Now let's compare this right here to the problem above. What's the difference when I get to this step between this guy and this guy? The parentheses. When I had it multiplied out, 2y minus 5, my first step was to move 5, then move 2. When I have it factored out, could you multiply that in? Sure. But if it's already factored out, we might as well keep it. So what's the steps here in moving?
Divide by multiply it.
Divide by negative 3, which is the same thing as multiplying by what kind of 1/3? The negative has to come with it. The negative either is like with it because it's negative over here or it's not. So I would do negative 1/3 parentheses x plus 1 cubed equals y plus 2. And then I move the 2. So we're just kind of trying to show you all the different cases because it does matter. Is it distributed in or is it not? That is going to change the order in which you solve. Like this 2y minus 5, it was not factored out. This was factored out. So I had to move that number first and then the plus. So it just kind of depends on what it looks like. You could do negative 3y minus 6 and then it would look like this. But the way it's set up, I just went with it because it was already set up this way.
But it's still, you still get the same.
Your answer would look a little bit different because
What do you have the 2?
I'm going to move it. I'm going to move it right here. Your answer would look a little bit different, and let me kind of show you what I mean by that. X plus 1 to the 3rd minus 2. So you know how in the problem right above, let me put this, I'll leave this here so people can see it, but let me talk about right here. In the problem one right above, when I wrote it like this, 1/2 parentheses this plus this, I could technically distribute that 1/2 and have a different number right there. That's what would happen if you did it the other way. Yeah. You would have it written as like, this is distributed and the other one wouldn't be, if that makes sense. So, if there was a test or something on this, there would be multiple answers that I could potentially accept, but I just kind of go with however the problem's written. I do that there. So try example 4 really quick, and then we're going to talk compositions. That will not take very long, and then it'll be homework time. Because you got a homework check next time. These aren't super hard, are they? They take a little bit of time. You got to be really well versed in your algebra skills, which is important. But again, when we get to solving these, you're not going to be isolating a variable. You're going to be solving for a variable. So you're going to have to do these same steps. It's just you'll actually have a number to work with. I moved over this 2 by adding. I moved over this 2 by multiplying. And y'all, if you're multiplying by, this has been another topic of conversation. When you multiply by the reciprocal, it is the exact reciprocal, not opposite reciprocal. We're not talking about perpendicular here. If this is a -2, I multiply by a -1/2. If this is a +2, I multiply by a +1/2. The negative stays with it, or it's positive the whole time. You don't need to be switching any of that, okay? Now, at this point, how do I undo? I got this by itself and said nothing in here changes. How do I get rid of that cubed? Cube root, sorry. Okay, now here's why we need the double parentheses, KJ. There is this factor, and there is the -1/2 in the front. Since there are 2 things over there, I have to technically cube both of those.
I just moved over the 3 before we did.
You can't do that
What we did last time.
because there wasn't anything in front. You have to get this parent function all alone. Last time, to get the parent function alone, there wasn't a number right there to move. So that's what I'm talking about. Like, we kind of put numbers in different places for each problem so you can see, like, when you would have to do that and when you don't. Okay? So then I would end up with, here's my cubic one here, inverse function. And it does have the double parentheses, and that is important. Okay? All right, let's talk about compositions real quick, because you do have some of these on your homework. Again, your homework has got 4 inverses to find, just like we just did 4 right here. And then you've got 2 compositions, so it's like a carbon copy of the notes right there. Okay, this is the property that we are checking. When we compose them, we are looking to see if they are equal to x. So we're testing 2 different things. We're going to do number 5 first. Here's f of x, here's g of x. We're testing out f of g of x. And what that means is we're going to put, we have done this already, okay? We're testing, is this equal to x? What is g of x?
That one.
It looks ugly. So I'm going to put cubed root of x plus 7 over 2 as the input of function f. Okay? It's kind of a lot to say. So function f says the x value is raised to the 3rd power. It is multiplied by 2, and then it is subtracted by 7. So I'm going to replace this plain x with this guy right here. Okay? All right, so watch. 2, open a fairly big parentheses. And instead of putting in plain x, I'm putting in the whole function g. But what else is happening to x in function f? It's raised to the...
3.
And then we subtract 7. Okay?
What's that equal? Is that just equal, like...
It's equal to f of g of x. This is what it's equal to. Okay? And I'm not going to keep writing that because I'm lazy. You can, but I'm lazy. Okay? All right, so what will happen if they truly are inverses is stuff is just going... I am so sorry you've had to get up like 10 times today. Is stuff is just going to unravel. All right? If I follow what's going on here, what happens when I have a cubed root to a 3rd power? They cancel out. And so I'm left with the big 2 on the outside times whatever was on the inside of that cubed root, which was x plus 7 over 2 minus 7. It already looks better. Now, when I multiply 2 times x plus 7 over 2, what happens to the 2's? They simplify to 1, so they are away. And then I'm left with x plus 7 minus 7.
X.
And so what does f of g of x equal?
X.
And that is a check mark. That's one thing that I have to show. What do I have to show now? The other way. G of f of x. If one works, should the other work?
Yes.
No.
Yes, they should. If one doesn't work, do you have to check the other?
No.
No. So sometimes it's easier when one doesn't, and you're like, oh, okay, it saves me. But if it does work, you got to show the other way. So this time, we're putting an input of 2x cubed minus 7 into g. Well, function g is the cubed root of your input, which is now 2x to the third minus 7 plus 7 all over 2.
What the heck? Wait.
I know,
Wait. Why'd you have the plus 7?
because right there, it's plus 7. You are putting this right there,
Okay.
So that's f of x.
Okay, I get it now.
is the input on G.
Yeah.
This was X originally. This little guy right here. You can put that in parentheses.
And then you're plugging that x into the.
I already plugged it in, but yes. Yes. Okay? All right, what happens here? Minus 7 plus 7. We already said that is 0. And then I have cube root of 2x to the third over 2. Well, what's 2 over 2? 1. And then I have cube root of x cubed, which is...
Alright.
So now I have shown. Do you see how it all kind of just unravels and you're like, whoa,
I don't like this.
maybe that's what you're thinking.
Nope, I know.
Wait, whenever you do that to the y, it equals like y and negative 1. So then wouldn't it equal x negative 1? Like whenever you do the...
Oh, no. I'm not switching anything here. I'm composing. I'm just like picking a different input. I'm not like switching my domain and range like I was before. This is all, these type of problems, I don't want you actually finding the inverse. I want you telling me, because these are compositions, therefore I know they're inverses. So I shouldn't have any negative 1.
Is it possible to find the inverse?
I mean, yeah, if I just said find the inverse, you could do that. But if I'm saying check with compositions, then you best be checking with compositions. So my answer is yes, they are inverses. Why are they inverses?
Because they're equal to x.
Because the whole thing. Did someone have their hand up over there? What's up?
So basically what you're doing is you're using the x in one of them and plugging it.
That's what it means to compose, yeah. Number 6, there is another typo. On g of x, you think that's supposed to be a 2 on that radical?
No.
It's supposed to be a what?
3.
Makes it a little bit more interesting. So let's do f of g of x first. So I am we're changing g of x to be a cube root of x plus 2. That is the input.
I have a question. Why do you need to write f?
Just to show that, like, I'm evaluating function f with this input. It just kind of helps me see where it goes. Like, because I'm saying, okay, f says cube your x. Well, here's my x.
You forgot the second plus 2.
Well, I'm putting it after. Like that. What happens when you cube a cube root?
Cancels out.
Correct. And so I'm left with,
X plus 2 plus 2. It doesn't.
Wait, but that's... What's
Equals
your super
x plus 4. So it doesn't.
so what does that mean? Are these inverses?
No.
Under the cube root.
This was, no. This plus 2 was outside.
The f.
So there, you don't have to do that one.
You don't have to do the other one. You just, like, to me, I just think, like, this is going right here. Which means I have to cube this and then add the 2. That's why this is in its own little parentheses. Okay? All right, so homework check next class. 7-1, 7-2 need to be done. You've got some time. These problems really can be worked rather quickly if you understand what you're doing. I've got answer key if you want to check. Make sure you're good to go. Check for my email about course schedules. It'll probably come tomorrow. So you can kind of think about what you are interested in taking next year. Retest. If you're retesting, you need to get yourself to tutorials. I've got power lunch tomorrow, second half, and the morning. I don't have power lunch on Monday. Did I tell y'all why I don't have power lunch on Monday?
No.
Oh, I'm so excited. I don't have power lunch on Monday because we're getting Babes for lunch, and that is my favorite place of all time, and I am eating for 2, and I am real excited, so I'm not having tutorials on them. You are welcome to come find me at Hall Duty, because I can help you then, but then when that 12:45 bell rings, get out of the way. I'm running to the library to eat, and I'm being I don't know, I might be in a food coma when y'all get here, but that'll be okay. You won't be upset, right?
No.